to me. We'll get started on those. Then we're going to try a malonic ester synthesis problem. So, aldol condensation. Okay, so let's see here. First one, I'm going to redraw the compound. So why don't I move this actually a little bit? I'm just going to move this down here slightly. And then what we'll do is we'll draw the second molecule, because this is our alpha carbon. So why don't we draw it with the carbonyl here like this? And then, I mean, you could draw it any way you want, but I'm just going to draw it like this with our 5-membered ring here. So the double bond will be between the alpha carbon and the carbonyl carbon. And therefore, the product is going to look like this. So this is our aldol condensation reaction. So we end up with an alpha beta unsaturated carbonyl. This is an alpha beta unsaturated aldehyde. And there we go. There's our 5-membered ring. And there's our final product. With the next one, same rationale. Here's our beta carbon. Sorry, our alpha carbon. Sorry, I got other stuff on the brain, I guess. Anyhow, so let's redraw a second molecule like this. So this is 4-heptanone. And our double bond is going to be between the alpha carbon and the carbonyl carbon. And thus, our final product is going to look something like this. So we'll have a double bond here. And then we're going to have 1, 2, 3 here. And then 1, 2, 3 like that. And that looks pretty good. Although my bond lengths are kind of funny looking here, I could probably make those look a little prettier. So 1, 2, 3, like that. The other one's not too bad. Okay, there we go. So a little bit of aldol condensation chemistry. So that's covering a lot of the chemistry in chapter 21 already. So that was question 21.17. If you want to go back into the solutions manual and explore that any further. Now I want to take a look at some malonic ester synthesis. So malonic ester synthesis. And malonic ester synthesis, we know that we're dealing with a malonic ester synthesis whenever we have some kind of acetic acid derivative. Anytime you have some kind of acetic acid-like molecule or something that has acetic acid as part of the molecule, that is not 100% of the time, but oftentimes it's a dead giveaway that you've got some kind of malonic ester synthesis. So if we go to question 21.68, let me just find it here in my textbook. So it says starting with diethyl malonate. So if we start with diethyl malonate and using any other reagent, show how you would make each of the following compounds. So the first one is this compound. So we have an aromatic ring, 2 carbons, and then we have, 3 carbons, and we have a carboxylic acid. So the part that we're going to get from the diethyl malonate is going to be all of this here. This is going to come from the diethyl malonate, and that means that this part here is going to come from our electrophile. So this is going to come from benzyl bromide, this compound, and then these 2 carbons, this portion, are going to come from the diethyl malonate. So this is going to come from diethyl malonate, and again, it says you can just assume that you have diethyl malonate as a starting material. So how are we going to work this out? Well, we're going to start with our diethyl malonate. So let's rewrite that here. So it's just the diethyl ester of malonic acid, and we discussed what malonic acid was in the carboxylic acids chapter. First step, we treat that with sodium ethoxide. Since the pK of this proton is around 9, that deprotonates it completely. And we could even just, draw the whole thing out. So you end up taking the diethyl malonate and deprotonating it. So let's see if we can copy that. We'll paste it over here. Nope, that would be too easy. If that would just work. There we go. So we end up with the doubly stabilized enolate like this. And then we're going to treat that with our benzyl bromide. So we have our benzyl bromide. Then it's just a straightforward SN2 reaction like this, and we end up with that piece, where am I? There we go. that piece attached here. So we have the methylene, and then we have the aromatic ring, like this. So what's the next step is to treat this with nothing more than aqueous acid and heat. So aqueous acid and heat. And remember, what that does is that converts this side to a carboxylic acid and this side to a carboxylic acid, but then you end up losing carbon dioxide in the process. So you have a decarboxylation. So it's a hydrolysis followed by decarboxylation, and that is going to give you the product. So you'll end up with this as your final product, nothing more than that. So remember, this is, if we count the carbons like this, 1, 2, 3, this would come from carbon 1, 2, 3, right? You end up losing CO2 in the process. In the first step, obviously, you hydrolyze the esters. So that is a malonic ester synthesis, and you need to know how to use diethylmalonate. So diethylmalonate, like that. Let's try another malonic ester synthesis question. So this is 21.68b, 21.68b. And this time we want to make this compound. So this compound here, which would be what? It would be alpha methyl propionic acid. So if we want to make this compound, you know, this part is going to come from the diethylmalonate. That means you need to add 2 methyl groups. And that can be done using diethylmalonate. So we start it with our diethylmalonate, like this. Oops. Our diethylmalonate, like that. Then what you need to do is we're going to treat this with sodium methoxide, followed by iodomethane. So we'll just put methyl iodide, like that. And that is going to install 1 methyl group. So let's pencil that methyl group in, like this. But remember, we still have another enolizable proton here. So we can do the exact same sequence again. We're going to treat it with sodium methoxide, the first step, and then iodomethane again. I'm just going to write it a little bit differently this time. And now we have 2 methyl groups installed. So I've got 2 methyl groups right where I want them. 1 here. Oops. And 1 here, 1 here, like that. And now all I have to do is treat that with aqueous acid, heat that up, the decarboxylation occurs. I end up getting exactly what I want. I end up with the carboxylic acid, just like that. So again, remember that the heat in the acid causes a hydrolysis, right? So what you make from the hydrolysis is this compound. So let me just draw the intermediate. And this is unstable, of course, but you end up making this compound where you have the carboxyl group on each side. This is unstable. This does not live, okay? It dies because it undergoes a decarboxylation. If you just redraw the compound like this, okay, you end up doing a decarboxylation where you grab this proton like this, right? And that forms an enol. So you lose CO2, right? Right here, you lose the carbon in those 2 oxygens as CO2 gas, and then you end up forming this compound, oops, this enol, okay, like this. Yeah, like this, and that is not stable, and that undergoes tautomerization to give you the final product. So it gives you this final product just like that. Oops. There we go. All right, let's try one more, and then we'll move on to the amines chapter. So I wanted to try a problem that involves the acetoacetic ester synthesis. So we'll pencil that down here. Acetoacetic, acetic ester synthesis. So for that, we need ethyl acetoacetate. And The dead giveaway that you have to use the acetoacetic ester synthesis is if you have some kind of acetone, moiety or piece in your molecule. So let's say you wanted to make this compound, right? You can see that this part here could come from acetone or propanone, right? So what would you need? You need that part to come from ethyl acetoacetate, and you'd need this part to come from benzyl bromide. So this is similar in scope to the problem that we looked at a few minutes ago. So we have our benzyl bromide, and then we have ethyl acetoacetate. You need to know the structure of ethyl acetoacetate, which is this. Oops, there we go. It's a little bit better. So how do we lay this out? Well, what we're going to do is we're going to start with our ethyl acetoacetate. This looks like this again. We're going to treat it with sodium methoxide, which is going to form the doubly stabilized enolate here. Then you treat it with benzyl bromide. Oops. There, benzyl bromide. And that's just going to do an SN2. So we're going to end up with this compound where we have our phenyl group and our methylene here. And then what we do is we treat that with aqueous acid. So we treat that with aqueous acid and we heat that up. And we end up with this. So let me just draw this as carefully as I can. We still have this carbonyl, but now we have a carboxylic acid here. So we hydrolyze this side to a carboxylic acid like this, and then we end up losing CO2 in the process, right? We make an enol here, we lose CO2 in the process, so minus CO2, and we end up with an enol that looks like this. So phenyl, or some methylene, we have a double bond here, we have this, and this enol undergoes tautomerization spontaneously to give us the desired product, so to give us the ketone. So if we draw that out very carefully, it's going to look like this. And this is the exact same thing that we had drawn earlier. These are identical. So this, again, is the acetoacetic ester synthesis.